have a good number of people here. I'm going to go ahead and just kick it off. I have a couple of slides. Are you ready to go, Ryan?
Yep, ready to go.
Okay, cool. All right, so let me share my screen real quick. I'm going to stop sharing here. All right. Continue. All right. Okay. Can you guys see my slides?
Yep.
Okay, cool. And I just want to transition. And I'm just trying to get used to this, like this Twitch stuff. So, anyways, welcome everyone. Thanks for coming to DC207 September edition. Still in quarantine, but I'm glad that we can all get together and chat about information security stuff. If this is your first time here, there are some new names I don't recognize. So DC207 is Maine's DEF CON chapter. My name's Ben, and I am the organizer for this group. We meet every second Thursday now in cyberspace, which is awesome, and I think that we're gonna keep doing that from now on because it's allowing some of our faraway friends like to get in on this. DC207 is all about InfoSec. InfoSec is awesome, so let's talk about it. And we like to talk about it with sort of a more practical twist on it, and we talk about DEF CON stuff. So if you like DEF CON, you're in the right place. One of the things I always promise is that with this group, you'll never get like a corporate BS sales pitch. It's like community curated content. So we're just going to keep it that way. So just so you know. There's a couple of things I just want to announce. So there wasn't that many people at our last meeting. We now have a Hack the Box team. If you're at all interested in joining our team, if you have any interest, please let us. Oh, I'm hearing a lot of feedback. Can someone mute? Okay. Hopefully that's better. So we now have our own Hack the Box team. So if you'd like to join us, just shoot me a message over at root@dc207.org, and we'll set you up in that team. We're also launching a Twitch thing. We're running it soft right now. So I'm just trying to see if there's like any big issues with it, and we'll probably do another soft one in October. But after that, I think we'll just kind of like open it up and let people join in. It's also a really good way to support DC207. As some folks know, DC207 is completely hacker run, if you will. So subscribing to something like this helps fund our efforts. And if you're familiar with the DC207 scholarship program, which we've talked about, applications are still open. We've only gotten a few applicants. We have already started looking at our applicants, and we're kind of narrowing down who we want out of that group. We're going to be leaving that open for probably another like 3 more weeks. So if you know anybody who is interested in getting some sort of certificate program or some sort of educational thing, send them over to scholarship.dc207.org. We want to give away money, so that way you can learn. So anyways, tonight is going to be awesome. Ryan Buteau is going to be presenting and dropping a new tool today called XSS Spider. XSS Spider? That's right, right? Yeah. Okay. Well, anyways, so yeah, I don't know. So anyway, so his talk tonight is entitled "When Stealing Credentials Isn't Enough." It's a very cool tool, and I'm very, very excited to have him joining us tonight. And with that, I'm just going to go ahead and kick that right on over to Ryan. So I will stop sharing my screen, and you should be good to go, Ryan.
All right. You guys see the slides?
I can see them.
Yes. Sure can.
Thanks.
Yep.
Hey everyone, thank you all for coming out to my talk, When Stealing Credentials Isn't Enough. Tonight I'll be releasing an open source tool that I've been working on called XS Spider. My name is Ryan Buteau. I'm an offensive security engineer and a full stack developer. If I could make a living playing drums, I'd be doing that instead. And as you guys can see behind me, I'm a little bit of a home brewer. Tonight, we're going to be talking about some website basics, what the different elements of a website are, and then how cross-site scripting works to manipulate them. We'll take a look at the attack scenario and problems that led to the creation of the tool, and then what the tool does to address them. To wrap up, we'll demo against a target site, showing some of the features, and then walking through the code that makes it all work. So kicking off the website basics, we have HTML. It stands for Hypertext Markup Language. It consists of various tags representing elements for the browser to render. For example, these H1 and H2 tags are headers. You can see how they're both larger than the rest of the text on the screen, H1 being larger than H2. The UL tag is for an unordered list and populated with list items. You'll notice bullet points here on the right, whereas an ordered list would have something like 1, 2, 3 or ABC. And lastly, in the form tag, we'll put things like text inputs and buttons that we'll use as a login. If HTML is telling the browser what to render on the screen, CSS tells it how to render. It stands for Cascading Style Sheets. This is the same HTML as the previous slide, but we've now added some CSS to it, changing the way it looks. It works by referencing any of the identifying characteristics of an element. In most of these examples, we're using the element tag, but additional selectors such as an ID, class, or other attribute are possible. Instead of selecting all three inputs, here on the top right, we modify just the input types, text and password. We're able to set things like colors, fonts, sizes, spacing, and even animations. The last component of a website we're looking at is JavaScript. So far, we've seen how to add elements to the screen and then how to style them. JavaScript is how we interact with them. Here at the top, we're selecting the login form we created and then adding an event listener. Listeners could be something like the mouse moving over the form or clicking. It could be a specific key press or a value being changed. In our case, it's the form being submitted. So let's tell the browser what we want it to do. We first define our URL, which is ourserver.com/login. And then we get the values from both the username and password fields. Because we're sending data, we want to set up a post request to our server and then provide it with our login values. After the request has been sent, we pop up an alert to tell the user that it's been submitted. Now that we have a general idea of how websites work, let's talk about cross-site scripting. Cross-site scripting, or XSS, is a client-side code injection attack. Client-side meaning that the actions are happening in the user's browser rather than on the server. Payloads are typically crafted with JavaScript, but leveraging HTML and CSS is also possible. There are a few different types of cross-site scripting. There's reflected, persistent, and DOM-based. And we'll take a look at each of those in the upcoming slides. So the first is reflected. Reflected cross-site scripting attack occurs when the website renders content based on the URL. For example, this URL contains a message parameter, the value of which is all is well. When the user clicks the link, the site renders a p tag with the text status:"all is well." Abusing this functionality, an attacker could send a victim to the same site, replacing the simple message with a script tag containing malicious code. The victim opens the link, executing the script in their browser. A bit different than the reflected attack, persistent cross-site scripting serves the malicious content right from the server. Rather than sending a link and hoping it's clicked, our code can be executed by any user on the site just by being there. Think of a comment section or public forum where you're reading content from other users. Here we have a nice welcome message, share with anyone who visits the page. Now replace that message with a script tag or some additional HTML, and the website is now injecting our code into the victim's browser. And lastly, DOM-based cross-site scripting occurs when the client-side code is loading content from a user-controlled source. Actions such as setting the inner HTML or running input through a JavaScript eval could result in a DOM-based attack. Think about an editor that allows users to enter HTML to customize the way they want their text to look. So in this case, bolded with the B tags. An attacker could abuse that functionality by, again, adding additional scripts or HTML. Now that we know the different types of cross-site scripting attacks, let's talk a little bit about what we can do with them. One of the most common uses is to steal cookies. Acting as an identifier for an authenticated user, if we were to steal a user's cookies and add them to our own browser, we'd effectively become that user, hijacking their session. Another use is stealing credentials. We can do this by popping up a login form or redirecting to an attacker-controlled site. Here, we're injecting an iframe pointed at our fake login and then using CSS to make it take up the victim's entire window. Once they've logged in, we can send them back to the original site as if nothing happened. This last example that we'll look at is defacing a website. This could be subtle, such as changing a few pieces of information on the screen, or as our code is doing here, replacing the entire page with our own content. So at this point, we've taken a look at the basics around how a website works. We've also learned about cross-site scripting and what we can do with it. I'd like to walk you guys through a scenario that I encountered during an assessment and talk about the discoveries that led up to the creation of this tool. So the first discovery is blind cross-site scripting. This is when the injection is sent to another area of the application or another application altogether. We're not really able to see what's going on behind the scenes. So let's go ahead and steal their cookies. Well, we can't. They have HTTP-only cookies enabled, which means that the values we want to steal are being protected by the browser. They can only be accessed during requests to the domain that they were assigned to and not by any of our client-side code. That's okay though. We can still work with that. Let's try to steal their credentials. We can't. There's no login page for us to clone. And even if we were able to steal their session or steal their credentials, it wouldn't help us because the application is locked down to internal access only. There's no remote way of accessing it. So that leads us to the creation of Access Spider. It executes as a cross-site scripting payload designed to exfiltrate anything the victim has access to. This includes all HTML, JavaScript, CSS, images, and it's extremely fast. The initial site tested was 800 unique asynchronous calls, and it was done in less than 45 seconds. Once the website's been extracted, it can be rendered fully in the attacker's local environment, which is huge for gaining an in-depth knowledge of the target, and then crafting custom payloads for our cross-site scripting finding to use. So the tool makes use of the serverless framework, automating the deployment and configuration. Everything is hosted in AWS, using Lambdas for communication and S3 for storage. The local web server is running Python 3.8 as well as the Lambdas. And then I'm also working on a Docker image for people who would rather self-host the tool rather than using AWS. So I don't want to bore you guys with too many more slides. So let's jump over to a demo and see this all in action. All right. Can you see the browser? Okay. Yep. All right. So this is just a really basic website, Access Spider demo site. It comes packaged up with the project on GitHub to test your instance and make sure everything is all configured, ready to go. So what we're going to do is we're just going to run a really basic jQuery call that's going to get our script. It's going to load it, and then it'll be triggered automatically and run. So we're going to pull in the Spider.js from our S3 bucket. And that's it. So it ran, it's done. It's a very small, basic website. So you can see it made 3 calls. And if we come over here to our bucket, you guys can see that it's already been populated. So we have index.html, we have our logo, and we have the CSS that styles the whole site. So I know that's a super basic version of this test. So to step it up a little bit and go with something a little bit more advanced, we have Matilde. So for anyone who's unfamiliar with Matilde, it's a purposely vulnerable web application. It's used for like a safe way to practice your skills and identify security vulnerabilities and how to take advantage of them. So this is just hosted locally right now in a Docker container. So I can click around and I can use the site. And so what we can look at right now is we have our attacker account, and it doesn't exist. We have no way of logging into the site. But what we do have is a way to add a blog post unauthenticated. So what we can do here is we can see if it's vulnerable to cross-site scripting. So we throw in a script tag, and we're going to set its source to, again, our S3 bucket, and we're going to point it at payload.js. So we're going to do this. It'll behave kind of like as a dropper, where our injection is loading payload.js, and then we can manipulate payload.js on our side to update with new type of payloads as we learn more about the application. So I'm going to go ahead and save this. And as I've saved it and it just reloaded, normally we'd wait for it to be triggered, but it just reloaded. We triggered it. And if we come back to S3, it's already done. So we have the entire contents of this website. We have index.html. We have all of its images extracted. We have all the different pages. All of the resources, the styles, the JavaScript, we have some PHP here. Anything that the website that we would have access to as a user was found and extracted and then sent to our external server. So if this was, in our case, an internal only site, I've now extracted that to a place that I can control. And I know that this stuff here doesn't really look very useful. It's all, you can't really even understand what the files are. But we have a server, a local server that we can run that does know exactly what it is. So using our AWS CLI, we're able to pull down this S3 bucket and then spin up a Python server that can host it. So this is our locally hosted version of Matilde using the contents of Matilde that were extracted. So you can see that they're nearly identical. We have all the same pages that we can access. We can look at any other information that the system has, like these logs. There might be some session information here that the user had access to that maybe we could use. There's some captured data. But what we can do at this point is take this locally hosted version of the website or the web application and learn more about it and figure out how it works, and then see if there's something that we can take advantage of or customize with our payload, and then modify our payload.js for the next time it gets triggered. So what we can do here is look into this account registration form. So we can inspect the element. We can edit it as HTML, and I can take all of this here, and I'm going to copy it into VS Code. So let me just swap over to VS Code. All right, so now you guys should see VS Code. Here's our HTML that we just extracted from the website. It's a registration form to create new users. So there's a few things here that we're going to need. The first is our URL. I'm going to live code this, and I'm not a super fast typer, so this is going to be real painful for some people. We have our username. We're going to set this to attacker. We need a password. Set that to our super secure password of password. We also have this signature. We'll just set this to XSS user. And then lastly, we have this button. So we'll set button. And the value here has already been provided, so we're going to set that to create account. So just to go over this a little bit, we have a form, and this form is going to be submitted when the submit button here is clicked. So the website is going to take all this information that the user would normally enter into these inputs, package it all up, and then send it to the server. The server is going to process the input and then create that user as long as everything's all valid. What we're doing here is we're doing the same thing, but in JavaScript. So we're extracting things like the action, which is the page. We know that it's URL encoded. So we're going to URL encode all of our parameters. We have our username, password, confirm password, signature, and then the button. So let's start making our call. In our payload, we've already brought in jQuery. I'll show you guys that after this demo here, but we have jQuery available to us, which is going to make some stuff pretty easy. So we have post, and we're going to put in our URL. And then let's start grabbing our parameters. So the first one here is called username. So we're going to have username equals, and we're going to set this to the username we provided up top, which is attacker. And then we'll do it with the next ones. So after the username, we have password. Then we have to confirm that password. That'll just be the same variable that we defined up top. Next, we'll have the signature, which they call my signature. And the last piece is this button. So they call it register PHP submit button. And we're going to set that value to our button up top. I'm just going to double check this just so it doesn't mess up. So we have our URL, passing that in. We have our username, we have our password, we have our signature, and now we have our button. All right. So what we can do with this is we can take our previously uploaded payload file, and instead of calling the spider, what we'll do here is we're going to make our call to create a user. So I've got that saved. And I'm going to swap back to the browser here. So we have our public S3 bucket, and then we have our private S3 bucket. The public one is where we're hosting all of our files. We've got this uploaded. We just confirm that it is the new values here. So we have our get script is commented out. We've got our new create user post. So what's going to happen now is when we come back here, the next time our stuff gets triggered, actually, it wiped out. 1 second. So next time that it gets triggered, we're going to be able to come here. Now our user's been created. So using the spider, we first we identified a vulnerability, a cross-site scripting vulnerability that we then put the spider into. When the spider gets triggered, it extracts the entire content that that user has access to into a resource, an attacker-controlled resource, in our case was our S3, that we could then use to host their application locally, learn more about it, find some interesting functionality, and then abuse it. So in this case, we generated a user, and now we have access to this site. So what I can do now is I want to walk you guys through a little bit of the code, how it works, and what it all does. Like that. All right, so the first thing here is our payload. This was the first file that gets brought in. It's kind of, like I mentioned, it kind of acts as our dropper. It's something that is persistent and stays in the application and allows us to manipulate what it's actually going to do on our side, on the server side. So we can update our S3 and then modify what actually gets triggered on the victim's browser without ever having to change the payload in the application. So what it's going to do first is, as soon as it gets pulled in, it checks to see if jQuery is defined. If the website is already using jQuery, we're going to move on, and we're just going to call execute. But if it's not defined, what we're going to do is dynamically load jQuery into their application. And then once it's been loaded successfully, then we're going to call execute. We do this because the spider makes a lot of use of jQuery. It just makes things much faster, much easier to use, a lot less code on our part. But this, of course, could be used without it. What execute's going to do by default is it's going to call getScript. It's going to call the spider URL, which we've defined up here above. So if you were to go to GitHub and make a clone of this repo, this value here is going to be different. You're going to set something up specific to you and your environment, and it needs to be a unique identifier for your setup. You would just change this to be whatever. Once we've brought in the spider, this is where all the actual work is going to happen. So up here at the top, we're just going to start basically defining a few different lists for each type of element that we're going to grab. And then there's a blacklist. One really important thing that I want to make a note of, and I'll probably say it again as well, is the spider clicks everything. Anything that's in that web application that can be interacted with, this is going to interact with. So keep that in mind, that a lot of older websites, for example, Matilda here, you notice that I had to re-upload that payload. It's because the spider clicked on resetting the database. And so it removed the whole content that I had uploaded. So think about that, but in like a production environment. There could be a button that's like set to delete stuff, delete all the users or some data, make really bad changes that you're not going to want to make. Especially if you're just doing a pen test, you don't want to actually blow up their system. It's not super good. I mean, it is a good finding at least to have that they should have not been developing that way. But I have a basic blacklist here. So we don't want to click on anything that's like logging out or signing out. We don't want to delete anything. And this one here was actually added specifically for Matilda. if you click on the enforce SSL button in Matilde, it blows up the whole thing because there's not an SSL certificate installed, and so it refuses to return any responses. So I have that blacklisted. So the next piece here, you'll see the store data URL, and this is kind of what I was mentioning about. If you were to clone this right now, this would be the value that's in there. It doesn't work, doesn't do anything. You have to set up that part of the infrastructure, which is all automated, so it's super easy to do. But you would put your URL here. So when the document's ready, so basically when the page has been loaded, this is going to trigger first, and it's going to grab the Windows location. So this is the base URL of whatever site that you're on. It's then going to grab the current path, like wherever it is currently in the application, clean up the path, grab its HTML, and then it's going to upload that to our server. So it's going to steal that page, send it off to our attacker-controlled resources, and then it's going to go into process HTML. And this is where all the real work goes down. It's going to extract any links, scripts, styles, icons, and images that's in that HTML. And then depending on what type of element it is, it's going to be processed differently. So the links, scripts, and styles are all processed as elements, whereas any images and icons are processed as images. There's some extra steps that are involved, so it's just a separate function. So for each of the elements that get passed into this list, it's going to go through, it's going to clean up the URL, make it something easily worked with by the spider, and then it's going to check to see if it's already scanned it. If it has, it moves on. It goes to the next item and ignores it. If it hasn't found it yet, it adds it to the list, and then it starts processing it. It's going to get all of its information. It's going to then upload that information and then move on to the next item. In certain cases, though, if, for example, it's a link, we want to do that recursively. A link is going to open up another page on the web application. So then we're going to take the HTML from the link, and we're going to pass that back into the previous function that we just looked at, where it's going to then locate all of the elements in that new page, all of the links, the scripts, styles, icons, images. It's going to do this until there's nothing left. The images are, like I said, processed a little bit differently. So we're going to bring in the data from the image, and then we're going to load that into just a canvas element, basically, a little hidden canvas element in JavaScript, and that's going to allow us to convert the image into its base64 counterpart, which then allows us to process it in a way that we can send it cleanly to our lambdas to process and store in S3. And lastly here, there's this function is the upload data. So we're making asynchronous calls using Ajax to post this data to our server. And again, that's going to be things like the base URL, the path that that page was on, including any parameters, and then the contents of that page. So it's going to package all that up. It's going to send it out, and then it'll move on. And because it's all asynchronous, it allows us to make a lot of calls very quickly. And here at the bottom, we just have the convert image to base64. This is where it gets loaded into a canvas and where we clean up the path and make it readable. So that's the spider. The server-side resources here, the handler, the lambda. And all that's going to do is store the data. So up here, we define our S3 bucket. And then we're going to check to make sure that something was actually sent. If it was, moves on. It's going to extract the raw path that the page was on, and it's going to process all the different parts. This question mark here is basically saying were there parameters or not. And so if there were no parameters, and there's nothing really there to work with, it's going to just default to calling it index.html. Like the basic path of a website usually doesn't say /index.html. It could say something or nothing. And we're going to just make it say index.html. So if there are parameters, we're going to process those things a little bit differently. We're going to separate the parameters from the page. And we'll use the parameters as a file name so that we can find it easy later on. So when I was showing the S3 bucket and everything kind of looked like, you know, jumbled characters, that was just an MD5 hash of all of the parameters just to name that file. But this is converting everything into a way to cleanly store it within S3. And it returns a 200 and moves on. And that's it. So that's the Lambda. It handles every individual call, spins up, runs super fast, and then stores the data and closes down. The server is what we run locally. This is how we're actually going to view everything on our machine. And it's going to look extremely familiar, so I'm not going to go through all of this, but it's basically the reverse of the handler. The handler is taking all of the web content, turning it into something that can be stored cleanly in S3. And then this is taking all of the website content, the calls that are being sent locally, and then making like checking the file system that you downloaded from S3 to then find the proper file that call belongs to, and then returning it to the browser. We can run it on whatever port here that we want. We have it defaulted to 8080, but when you spin up this server, you can set it to whatever you want. Then the last piece here is what makes it all tick, really. Like it's going to set up the entire backend, set up your website. It's going to set up all the buckets. And this is all serverless. So it's a serverless YAML file, and all you're going to have to care about are these three things here. So if you were to clone this, you could set your service name up here, give a name for your S3 bucket. The payload bucket is the public one, and then your server is your private one. So name those whatever you want, and then just whatever you use here for a name is what goes into you know, these areas here, your server bucket, your Lambda, and your payload. That's where these come into play. What it's going to do is set up 2 S3 buckets, a third if you include the serverless one. It's going to set up your Lambda, and then all of the information that AWS needs to configure things, all the policies and roles, what things have access to what, is all right here, and it's going to handle all of that for you. So that's kind of it for walking through the code, and I'm not really sure how long that took, but I have time for questions, I'm sure. You can find this stuff at our Science Biking Labs GitHub. There's also a blog post that goes into a lot of details, very similar to what I just went over. So you can find these links. I think we can send this out at the end of the talk. And that's it.
So Ryan, how easy is this to, like, oh, actually we got a question from Zach. Ryan, do you need to worry about executing malicious code that may have already been injected into that site with the spider? That's devilish.
Yeah, I mean, it's Matilda, it's public, it's Docker. Anyone could have put anything in it already.
So Ryan, if I wanted to set this up, like, not in AWS, is that easy? Is that hard?
Yeah, so I'm currently working on a Docker file that will allow you to spin up your own image locally. You can host this on your own server. It's going to replace all the AWS side. So it's going to be, if you have like a $5 a month Linode server, you can just spin up Docker on that, make a container, and then host it there. And then for that, you would just change out your URL to just be your IP address for your server. And then it'll have everything contained within there.
Ryan, what about logging on the server while you're doing this?
It's going to be extremely noisy. If someone's watching logs, they're going to see a call being made for every one of the calls that this spider is going to make. If it's being logged on server side, it's going to be a lot, yeah, very quickly. So the initial assessment that I was doing was, like I said, like 800 calls in less than a minute. I didn't hear anything, so it got by. But yeah, if people are paying attention, then it'll be noisy.
And I assume those logs will point back to that S3 bucket.
Yep.
Okay.
But I mean, as fast as it is, like 40 seconds, you said in the beginning for like 800, like within like realistic time for somebody to react, you already have the whole website. So that's
Yeah,
kind of crazy.
I can actually share. I'll show. I'll rerun it on the Matilde site. I'm just going to re-upload the actual spider payload, and then I'll open up console. I have debugging on the script. So when I save this, it's going to trigger the script. And these are all of the calls for this entire application. Every single page, it's printing out the name of the page and then the encoded file information that's actually being sent as the body. And it's about done. Yeah, so it's done. So these errors here are just from Matilde. They trigger when you hover over stuff. I'll try and find some of the actual content here. So this is what it actually is sending along. So the site here is localhost. The path is index.php, and then this question mark here is the parameter. So toggle bubble hint, and then setting the page to PHP errors. And you can see the names of all of the pages that it's extracting at that time. So yeah, it's pretty fast.
That's awesome. Justin is asking, have you thought of a way to prevent the spider from spidering? Server-side throttling, maybe?
I haven't looked into doing any limitation on the spider other than the blacklist for now. Yeah, if it doesn't match any of the text that's in that array, it's going to click it, it's going to interact with it. But there could be, you could put in a sleep and you could throttle it just to slow it down if you really didn't want it to get picked up. But at the same time, someone is on the website, they are using it. So you kind of want it to be fast right now, because if they were to click away, the script stops. That's another thing that I'm looking into, is a way to kind of create like a behind the scene process with the calls, so that even if the user was to leave the page, it would still be going and could still be persistent. I think like Beefhook can do that. So if I can figure out how they do it, I can maybe extract that chunk of code and put it in here.
Yeah, like, do you know how many requests it makes? Or do you roughly know how many requests it made just with that one run?
Yeah, so the way I found out was just by downloading that S3 bucket and then just counting the number of files that were there. I think the initial proof of concept, I just added a counter to the spider itself, just to tell how many calls it was making. And so that's how I got that 800.
Yeah, that's cool. So that's a lot, but you know, some throttling. I think application throttling I see out in the world, it's usually like 1,000 and up sometimes, because like they want to be very super careful. I've seen lenient against that. So even if you had something, it might not even be useful to you. You probably couldn't even detect it or block it, which is crazy.
Yeah, you could test if it can be detected. Just run this like you know, like I did here. I ran the spider directly. I didn't even need to find a vulnerability first. So if you wanted to just test the throttling of your site, like could you detect someone exfiltrating the entire thing? You could just run the spider as a test. So.
Avi asks, do you ever feel like the Cookie Monster saying nom nom as you steal all the cookies?
Every time I steal cookies. That's why I was so disappointed when I couldn't, and I had to make a spider so I could steal other stuff.
This is really cool. I don't I shared with you in the past. Like, I don't think there's anything else quite like this out there. It's really interesting, and it fits a fascinating use case. Like, stealing like entire websites from users who you might not even have access to, that you can pivot to, is really awesome. So what's the future plans for the development on this?
So after the Docker container, the Docker file gets written, I want to build off of this tool a little bit. There's Docker, and then there's the persistent, like underlying, just a way to get persistence in the browser, like a bhook. And then once I have that figured out, the next step is going to be kind of like a spin-off tool of session hijacking through cross-site scripting. So similar to how we're extracting right now the entire website and hosting it locally, if I extracted just the one page that it landed on, and then I could show that, like on the attacker side, I could just render that in the browser. If I was to click something on the attacker side, post up like some kind of a query, that the spider could then check and say, okay, I need to go here next, and then go to whatever that new page is, steal that, send it back to the attacker. So you can kind of like near real time hijack the user session through cross-site scripting. And that'll be the next step. So even if the credentials, even if the cookies are protected, and you can't get at them directly, even if there's no login form that you can steal passwords, it would still be an indirect way to gain control over that user session.
Justin's asking, would this work with PWAs or hybrid mobile applications?
No. I tested it out on, well, I guess it's a mix. I tested it out on one basic one. The blog site that I have linked in the presentation, I just ran it on there, and it works fine. It pulled out all the JavaScript, it pulled out all of the posts, the images, it all worked great. To do something that's a little bit more advanced, like any of the other SPA frameworks, it didn't really work super well. It extracted stuff, but not, it wouldn't render. So it's a mix. It would be interesting to kind of figure that out, but yeah.
Yeah, very cool. But still, you can get something at the very least.
Yeah,
cool. Yeah.
A lot of those SPA frameworks don't have cross-site scripting that works the same way as like the sites that I use tonight as a demo. So it would be a different. It might almost have to be a different type of tool as well.
Yeah, it's awesome. Do you have any more questions for Ryan? Don't be shy. You can chat if you want to. I don't know. It sounds like you explained everything excellently, Ryan. This was great.
Yes, she did.
Thanks,
Thank you,
Ryan.
Ryan.
Yeah, thank you, Ryan, for developing and sharing this content. Like, really, I think like someone from like me, like I'm not a developer, so like, having an arsenal of really cool tools to use, and having a development community working on that kind of stuff, that's awesome. So big kudos to you. Thank you. Virtual applause. Woo.
Thank you.
Yeah. I see Justin clap his hands in emoji, so that's good. Cool. So so as always, DC207, we're going to give away some stuff. Today we don't have anything too exciting, but we do have one of these awesome DC207 shirts. If you haven't gotten one, right? Yeah. So here's the thing. Ryan actually got this, and I liked it so much. I was like, I want one. So I got one in the same color, so we're matching today. So we're going to give away a DC207 shirt, now actually available in so many different colors. I'm doing them right now. If you want one, by the way, please do support the scholarship. They're on sale at our Swag Shop for about $30. So if you are interested, you can get one. But let me spin my wheel of fortune 1 second, and I will find out who wins tonight. All right, can you see my wheel picker? Okay, cool.
Yes, we can.
Awesome.
Yes, we can.
All right. Okay. The suspense is on. Okay. Let's see. Man, this is long. Oh, we have Eric. Hey, Eric. So if you just want to like PM me your address and shirt size and color preference, I can. If you just like send me your email address, we'll chat over email and figure out how to get that set up.
Yeah.
Okay. But yeah, so that's really all we have tonight for DC207. Thank you so much, Ryan, for your work and your presentation tonight. This is going to go up on our YouTube channel, and if anybody was wondering why I looked so distracted through this whole presentation, it's because I was trying to fix the Twitch. It was a failure. So maybe next time. But anyways, thanks everybody. I hope to see you in October. Please register. We're still working on the next talk, but again, please register. We're going to have some great content as usual, and you can come by and talk with us. So anyways, thanks so much. Have a great night.
Thanks, Ben. Thanks, Ryan.
Hey guys. Bye guys.
Thanks, guys. That was great.
Thank you guys for coming.
Thank you.
Great job, guys.
Thanks, guys.